This is set C, QTSS 2019 Prelim. Question number 2. So the student accidentally mixed 50 cm3 of hexane and 50 cm3 of sodium chloride solution. Now you need to know that hexane is actually a liquid at room temperature and pressure. So in general, for the alkane, methane, ethane, propane, and butane, all these are gases. Now likewise for the alkene homologous series, the ethene, propene, butene, all of them are gases. Then after that, pentane, hexane, heptane, all of them are liquid. All of them are liquid. So beyond butane, right? Or for alkane molecules larger than butane, all of them are liquids. Likewise for alkene. So pentene, hexene, heptene, all of them are liquids. And alkane is a main constituent of petroleum, of crude oil. So hexane is actually like oil. Okay, it is a liquid, it's a liquid oil. So if you want to separate oil and sodium chloride solution, you have to use separating funnel. So separating funnel is used to separate two immiscible liquids. Two immiscible liquids. So for example, oil and water. That is what separating funnel is for. Question number 7. Which observation suggests that the substance cannot be an element? So electrolysis of the molten substance gave two products. So if this happens, it means that the substance is a compound. Because element, the definition for element is that element cannot be broken down into simpler substances. Question number 9. So this is a structural formula of hydrogen peroxide. So from here, we can see that the total number of electrons used in bonding. Okay, so one line means 2 electrons or one pair of electrons. So we have 2, 4, 6. Okay, so 6 electrons used in bonding. How about the number of electrons not used in bonding? Now for oxygen, the electronic configuration is 2, 6. And for each oxygen, only 2 electrons are used in the sharing, are used in bonding, only 2 electrons. Because one line here means 2 electrons. 1 electron belongs to hydrogen, 1 electron belongs to oxygen. So for each oxygen, only 2 electrons are involved in bonding, which means that for each oxygen atom, there are 2 plus 4 electrons not involved in bonding. So each oxygen, 6 electrons are not involved in bonding. Only 2 electrons in the second electron shells are involved in bonding. So 6 electrons not involved in bonding. For 1 oxygen, 2 oxygen, there will be 6 plus 6, so 6 times 2, there will be 12 electrons not involved in bonding. Question number 10. So which substance is not a possible constituent of fiberglass? So fiberglass contains mixture of ionic oxides. So this is an ionic oxide. That means metal and non-metal. This is an ionic oxide because chromium, it's a metal. Oxygen is a non-metal, so ionic oxide. Giant covalent oxide. This is a giant covalent oxide. Silicon dioxide is in the syllabus. It's a giant molecule. So left with this one. So this is not a possible constituent of fiberglass because we know that the rest are either ionic oxide or giant covalent oxide. Here the structure of oxalic acid is shown. So from this structure, you need to know that there are 2 COOH, 2 carboxyl group. And you should know that the COOH, it will undergo partial dissociation to form 1 mole of hydrogen. This part will break up to form COO minus H plus. Okay, and then this COH, likewise, it will form COO minus as well as H plus. So 1 mole of this molecule would produce 2 mole of the hydrogen ions. That is what is special about this structure. So a 25 cm3 solution of oxalic acid reacts completely with this aqueous sodium hydroxide. What is the concentration of the oxalic acid? So first thing we need to know, we need to find out how many mole of sodium hydroxide are there. So the number of mole of NaOH would be 15 divided by 1000 times 2.5, and that would give us 0.0375 mole. Okay, NaOH. So 1 mole of NaOH would produce 1 mole of OH minus. So which means that the number of mole of OH minus would be 0.0375 mole. Okay. So since the oxalic acid reacts completely with this sodium hydroxide, we can further deduce that the number of mole of hydrogen ion would be the same as the number of mole of hydroxide ion. Now, since 1 mole of oxalic acid produces 2 mole of hydrogen ions, we should know that the number of mole of oxalic acid, OA, is 0.0375 divided by 2, which is 0.01875 mole. Okay, because every 1 mole of oxalic acid produces 2 mole of hydrogen ion. Every 1 mole of this produces 2 mole, 2 times 0.01875, which is 0.0375 mole of hydrogen ion. And since the question wants concentration of oxalic acid, we can just take the ratio of mole divided by the volume, and the volume is given, which is 0.025 dm cube, and that would give us 0.75 mole per dm cube. So this is the concentration of the oxalic acid. Question 23, correct result of adding oxidizing agent. So you should know oxidizing agent reacts with reducing agent. So Ki, potassium iodide, it's a reducing agent. That's why the oxidizing agent would react with the potassium iodide. Potassium iodide, original color, it's colorless. So it will oxidize the iodide, the I minus, to become I2, and that's why it is brown. Oxidizing agent, reducing agent reacts. Question number 36. Which of the following statement is true of the hydrocarbons? So let's look at answer A. Hydrocarbons 1 and 2 are in the same homologous series. So hydrocarbon 1 decolorizes bromine, so it must be an alkene. There is a carbon-carbon double bond. And hydrocarbon 2, no reaction, so it is not an alkene. So 1 and 2 cannot be in the same homologous series. Okay, how about hydrocarbon 1 is less viscous than hydrocarbon 3. So hydrocarbon 3 is more viscous. So recall that in any homologous series, let's say in alkane homologous series, so as the molecules of the alkane homologous series increases, so for example methane, ethane, okay, further you have pentane. So as the molecule of the alkane increases, the state of matter for the hydrocarbon would change from gas to liquid. So which means that hydrocarbon 3 is a larger molecule compared to hydrocarbon 1. 3 larger molecule compared to hydrocarbon 1. And the larger the molecule, the viscosity will increase. The higher the viscosity. Yeah, viscosity is a measure of how easily the hydrocarbon flow. So if the hydrocarbon can flow very easily, viscosity is very low. If the hydrocarbon can flow very, very slowly, viscosity is very high. So as the molecule become very big, okay, very long, then the ease of flow decreases. That's why viscosity increases. So viscosity for hydrocarbon 3 is more than the viscosity for hydrocarbon 1. So B is correct. Question 39. Okay, a portion of the chain of one such polymer is shown below. So this is a polymer. A molecule of this polymer contains 40 hydrocarbon atoms. How many molecules of monomer are required to make one molecule of this polymer? So this is a polymer, and you can identify the repeat unit or the repeating unit. So you can see the pattern. So this part is repeating. Okay, CH2, and then all the way to the bracket. CH2 all the way to the end of the bracket. So this is the repeat unit. Now the bracket means that it is a branch chain. So if you can draw the structural formula, it would look something like this. CH2, CH, and then this bracket is the branch. CH2, CH2, CH3. And then after that you continue. Okay, so the monomer basically is that there is a carbon-carbon double bond here. There is a carbon-carbon double bond. So this hydrogen. Okay, so this is actually the monomer. Okay, so this one, this line here, remove it. So this is actually the monomer. So how many molecules of monomer are required to form one molecule of this polymer? Given that the polymer, a molecule of the polymer contains 40 carbon atoms. So this is the monomer, so you can count how many carbon atoms are there. 1, 2, 3, 4, 5. 5 carbon atoms. And the polymer contains 40 carbon atoms. So 40 divided by 5. So you need 8 of these monomers. Okay, question 40. Okay, the structure of a polymer. So the question asks, which one of the following options show the correct monomers? So there are 2 monomers for each answer. So which means that this is a condensation polymer. So this one is a condensation polymer. So take note, this is COOH. So the OH is, the CO bond is broken. Okay, look further. Look further. So this is likely to be carboxylic acid. Look further. Then over here you can see. So this is a CONH. CONH is the amide linkage. So the 2 monomers actually join right here. So which means that this is one monomer. Okay, and then this is another monomer. All right, so you can see that this one is actually the same. So let's say 1, 2, 3. 1 and 3 are actually the same. 1 and 3 are actually the same. Then look further. 2 and 4 are actually the same. So take note, there is an N here in this diamond. In this diamond shape, there is no N here. So these 2 are 2 different monomers. Yeah, so the monomers, the 2 monomers are this and this. Okay, so this one, add in the OH because the OH are the atoms that are lost. And then over here, this is an amine, NH2. So the H is lost. Yeah, so you join back the H, so become NH2. So join back the OH, becomes COOH. And then likewise for this, you join back the OH. And then you join back the H. Yeah. So this is condensation polymers, 2 monomers.